Hey guys, this is Mrs. Weiser. So today's lesson is all about absolute value, which I'm sure you've never heard of before. The goals for today's lesson, so what you should be able to do by the end of this lesson is, first of all, find absolute value of a number. And as we go through this, I think you will find that's going to be the easier one. The second one's a little bit harder. I can compare the absolute values of numbers in real world situations. That can get really tricky, especially when we talk about real world situations. So before we get into this, I just want to take some time and review a couple things to help you understand what absolute value is. So remember the very first lesson we started on integers, where we were writing positive and negative numbers as real-world situations. And some of those involved elevation. An elevation of an object tells you its distance above or below sea level. And everything that was above sea level, we used positive numbers for above sea level. And anything that was below sea level, we were using negative numbers to represent those. So I have a chart here below, a table, with some objects and their elevations. So a mountain at 2 kilometers, a fish at -1 kilometer, a sunken ship at -4 kilometers, and an airplane at 4 kilometers. And just to review what these numbers mean, so if we talk about the fish at -1, just the fact that the fish being at -1 means the fish is 1 kilometer below sea level. And let's talk about one more example. So the airplane at 4 kilometers. That means the airplane is 4 kilometers above sea level. So what we're talking about here, that 1 kilometer below sea level for the fish and the 4 kilometers above sea level for the airplane, that's actually absolute value. So the absolute value of a number is its distance from 0 on a number line. That's why on the other example, when we said the fish was at -1, and we said that means it's 1 kilometer below sea level, we were actually talking about its absolute value, its distance from 0. So let's look at an example. These bars that you're seeing right here that are around -4, that just means we're asking for the absolute value of -4. It's a way to write absolute value. So this question right here, it's saying what's the absolute value of -4? Well, if we plot -4 on the number line, so right there, and we look at how far is it from 0, because that's what absolute value means, is distance from 0. It's 1, 2, 3, 4 units from 0. 4 units from 0. So if we were to write its absolute value, the absolute value of -4 is 4, because -4 is 4 units away from 0 on the number line. I'd maybe pause the video a little bit and fill some things in on your notes here. The next thing I want to talk about absolute value is that because it represents distance, its value is always going to be positive. And we're going to do a couple examples here to show you. So let's do the absolute value of -3. Remember that these bars that you're seeing here that are on both sides of -3, that means absolute value. So we're having to find absolute value of -3. Well, if we count the units, 1, 2, 3, this is 3 units from 0. So the absolute value of -3 is 3. All right, the other example that we have here has bars on both sides of 5. So that means what's the absolute value of 5? Which means we're just finding the distance 5 is from 0 on the number line. If I look here, it's 1, 2, 3, 4, 5 units from 0. So the absolute value of 5 is 5. So you can see that the absolute value of -3 was 3. The absolute value of 5 is 5. Okay, these are examples to show you that no matter what number we're finding the absolute value of, that value is going to be positive because we're talking about distance and we can't really have a negative distance. One common mistake with students when they start finding absolute value is they think that it's just the opposite of the number, and that's not true. So for -3, that absolute value, it did happen to be the opposite of -3, but when we found the absolute value of a positive number, it definitely was not the opposite because absolute value is always going to be positive. Okay, now that you've had some time to practice just finding absolute value, we're going to get to the tricky one, okay, where we start to compare things with absolute value. So just a reminder, with real-world situations, you can think of absolute value as the size of a positive or a negative number. So as we start to compare the absolute values of two numbers, remember that absolute value is the distance something is from 0. So the farther a number is from 0, the greater the number's absolute value. So I have some examples here for you. As we talk about negative numbers, the absolute value is going to get larger as the actual value gets smaller. And that's kind of weird to think about, but remember on a number line, the farther left you go, the smaller the value. And then obviously the farther left we go, the farther we're getting away from 0. So the farther left we go on the number line, the greater the absolute value is. So here's some examples to help you think about this. If we compare -4 to -2, we are comparing the actual values here. -4 is farther left on the number line, so it is less than -2. But if we go and we put bars around these numbers, now it doesn't mean -4 and -2, it means the absolute value of -4 and the absolute value of -2. We're comparing the distance that these numbers are from 0. Well, -4 has a larger distance from 0 than -2, so the absolute value of -4 is larger than the absolute value of -2. So as the actual values get smaller, and that's what we're showing here, this is smaller than this, the absolute value gets larger. This absolute value is larger than this. For positive numbers, it's a little bit easier. The absolute value gets larger as the actual value gets larger, and that should make sense because the farther right I go on the number line, the larger the number is. And the farther right I go, I'm also getting farther away from 0. So my absolute value is also going to get larger. So let's look at some examples here. If we compare 4 to 2, 4 is farther right on the number line, so it is larger than 2. If we look at their absolute values, now that we have bars around 4 and bars around 2, this means their absolute value. We're looking at the distance 4 is from 0 and the distance 2 is from 0 and comparing their distances. Well, 4 is farther away from 0 than 2 is on the number line, so its absolute value is greater than the absolute value of 2. Now, if that last part made sense to you, this is where it's going to get really hard. This is as complicated as we're going to get, guys, with absolute value. And that is comparing them in real-world situations. So this example says, compare the elevation and the depth of a fish swimming at -10 meters with a clam resting at -50 meters. All right, let's start with elevation. You got to think about what that means. Well, elevation is how high something is. So we're talking about the actual values here. So if we're going to compare the elevation of the fish and the clam, I'm going to write elevation here. The fish is greater than the clam. because the fish is higher up on the number line than the clam is. The fish is at negative 10 meters and the clam is at negative 50 meters. The fish is closer to the water, the surface water, the water level than the clam is. It's negative 10 meters, the clam is negative 50 meters. All right, the tricky part. If we compare their depth, now we have to compare their depth. That means something different than elevation. Depth means how far they are below the water. And since we're talking about how far they are from the water, which is 0 in this situation, now we're talking about absolute value. So now the fish would be smaller than the clam. And we're only talking about the fish's depth because the fish's depth is 10 meters below. Sorry, that's below, guys. Below the water, whereas the clam is 50 meters below the water. The depth of the clam is larger than the depth of the fish. But if we're talking about elevation, well, the fish's elevation is greater than the clam's elevation because it's closer to 0. But if we're talking about depth, now we're talking about its distance from 0. So the clam has a greater depth than the fish. All right, that is the end of the lesson. Hopefully you feel like you accomplished those goals at the beginning. What you're going to do from here is glue them into your notebook.